a favor, either somewhere, put your name somewhere here, or you can put it on the back. Put your name on your flip book. Are y'all done with this model? Yes. Okay. There you go. Okay, so the first thing, if you flip it open, this is what we should, oh, sorry. If you flip it open, it's down here. This is what you should see. Quadratics on calculator. Did you see that section? Quadratics on calculator. Okay, so we're just going to focus on example 1. Example 2 is just a problem solving method. So example 1 wants to know what is the solution to the equation, parentheses, x plus 1 squared minus 4 equals 30. Gosh. We still got people making their flip book. We need to get to the content. We need to fill in the information. We need to know what you're doing. Your test tomorrow is only on quadratics. So that's why I'm giving you everything off this objective on STAR, because it's going to be Starlight. All right, so to solve this, what do we need to do in order to solve? Who knows? Just looking at it knows what a first step could be. Nope, I don't need it to be in standard form to solve it. Huh? What? I don't need to expand it to solve it. Alejandro? Yep, you need to subtract the 30 first. The equation has to equal to 0 to solve it. That is the first step. That's what you have to recognize. So in order to solve, I'll just underline for solutions. Just make this little note because obviously we need to make sure we memorize this. The equation must be equal to 0. So by subtracting the 30, I'm now creating a 0 on the right side. And I'm going to rewrite the equation. So what would I write now? Yep, very good. Parentheses x plus 2. Yep, very good. Minus 34 is equal to 0. Can you just stop, Elizabeth, and let's just do this part, and then we can, because if we're still working on that we got to do that at the end. So now that it's equal to 0, now I can go straight to my calculator to help me solve. So in order to use the calculator, so when I'm using the calculator, for the calculator, you're going to have y1 would be the equation, because wherever the 0 is, that's your y, okay? So we would put this in the calculator, parentheses x plus 1, parentheses square, minus 34, but the y2 needs to equal to 0, okay? So get a calculator in hand, let's type this in, okay? Because let's make sure we know where to go to get to our solution. So we put these two in, then we need to graph it, and then go to second trace. And I'm just writing down the steps so you can have it. So let me get caught up to you. Parentheses x plus 2, close parentheses squared, minus 34. All right, so we graph, second trace, and where do we go?
0.
Nope, not 0. Intersect. 5 intersect, okay? And what do we need to do here? Yeah, enter 3 times, but guys, make sure you see your cursor, okay? Because where is the intersection located? Huh? On the x-axis. So like right now, I'm just going to move my cursor to the right and then see where it starts coming into the screen. Just hold it down. Sorry, here it comes. There it is. Now I can have an idea. Hit enter 3 times. See how we're going to get a decimal answer? This is the reason why we're practicing this. So there's 1. How many zeros does this quadratic have? 2. I need you to find both. Okay? So we're going to write it in the flip book. I'm going to continue with the steps. second trace, intersect, okay, and then move cursor to X intercept. Enter 3 times. So we got one of the intercepts was 3.83. Okay, who found the second one? Alejandro? Negative 7.8. And I think it was 3 as well, right?
Yes.
Okay, so make sure you have our solutions on your flip book. We know how to, if you want to write down the steps to review, you can add it to your flip book. Yeah, I know example 2 kind of got cut off, but this is just showing you how to find an answer if they give you an answer choice. Because they underline this word, which expression is equivalent. Okay, that means basically we're looking for same answers or same values or same numbers. Okay, same answer. If it's equivalent, it's the same. Okay, if it's equivalent, it's the same. So here's what I want you to do. I want you to put this expression as your y1 in the calculator. Okay, and I'm going to put my answer choice A as my y2. All right, I'm checking for them to be the same. All right, so I'm just going to get caught up with you. We put the expression that they give us in y1, which was, x plus 3, close parentheses, and then x minus 4. And then in y2, we're putting answer choice A, which was x squared, was it, let me see, minus x. Yep. Okay, minus x minus 12. Okay, so I'm checking for the same. So the fastest way to do that is just go to your table. How did we get to the table? Second graph. And see if they are the same values. If they are the same, then yes, it's equivalent. Does that make sense? Okay, so something like this, if they're asking for equivalent, you can check to see which one to match. So this answer would have been A. Okay, or you can say yes, A is equivalent. Now, the bottom of this flip of this page talks about quadratic regressions. We'll come back to this. You don't necessarily, odds are they won't put a quadratic regression, I'm sorry, it'll be a linear. So skip this for now. Don't worry about the bottom right now, okay? Go to the next page, which is talking about graphing quadratic functions. So flip it up. Graphing quadratic functions. We need to make sure you know, I'm just going to start all the key attributes to the quadratic function. So, little note, if I give you the function, use the calculator for help. Use the calculator to graph it for you. So go ahead and put y1 as your x squared plus 2x minus 3 in the calculator. I'm going to get one. Clear. We got, what was it, x squared plus 2x minus 3. All right, we want to graph it so we can see the attributes. Are y'all with me here? Okay, because I'm going to take this off the screen because you're going to look at your graph to answer, okay? So the first thing, on the graph, could we find the vertex? Just looking at it. Could we find where that vertex is? What is the vertex?
1.
Say it again. -1 comma -4. Yes, it's a point. It's the highest or lowest point of the graph. Are y'all looking at the actual, like right here, the vertex is here? Are y'all looking at on there? Okay. Do we have any roots?
Yes.
How many?
2.
Can y'all physically see them? Yeah, 1 and -3. We're done. I can see right here where that crosses the x-axis. So I'm just going to fill in x equals 1 and x equals -3. Now, does your graph have a max value or a min value? And what is that min value? What does it equal? Negative what? Where's the? Yep, -4. Our min value equals a -4. That's what we have. I'm just going to circle. Min value equals -4. All right. Now that I see the vertex, what would the axis of symmetry end up being? Yeah, so x equals -1. Done. On your graphing calculator, can you physically see the y-intercept? Yes, where is it at?
-4.
Not -4. All right, so we're going to write it as a point, 0, comma, -3. Y'all need to memorize that the y-intercept is when the x is 0. We need to see it as a point. Okay, now, our range for this parabola. Range for any parabola is what always?
Y.
Y. It is a y.
Greater than or
Greater than or equal to -4. It correlates with the y value in the vertex, guys. Since this graph opens up, it's greater than. Up is greater than, down is less than. And then our domain is always our real number. So you can just put the symbol for that. Okay. Now so I basically, what I need to make sure you can do is from an equation, and then if I give you the graph. So this one is an example of me just giving you the graph and you giving me the key attributes, okay? I do need you to add this because it's been a while. We talked about this last semester, about an open circle versus a closed circle, okay? An open circle means you have to use less than or greater than. It's not including, does not include the point or the value. So not includes, all right? So we can physically see this graph touches the x-axis, so it has an intercept or 0 or root. What's the value of the intercept? Look at the graph. What's the value of the intercept?
1.
No. 1 does not touch the x-intercept.
4.
Yes, 4. It's where it touches the x-axis, guys. So this is only 1. We do not include this one over here because it doesn't come down and touch. Does that make sense? So x equals 4. What about the vertex? Can you find that off the graph? Yeah, you can physically plot it. There it is. 2, 5. I think I like that you're answering or writing it before I'm telling you, because you need to be able to check your understanding based on doing it and then confirming. So looking at this graph, do we have a max value or a minimum value? What does the max value equal?
5.
Yep, max value equals 5. Good. All right, so we have a vertex. If you need to help you see it better, remember your axis of symmetry goes through that vertex. So what's the axis of symmetry?
X equals 2.
Yep, x equals 2. Good. Do we see a y-intercept? Yes, no. Where would it be?
1.
Okay, now, what do we notice at this point right here? It's open circle. So what does that tell me? It's not included, okay? So technically this does not, I'm gonna put DNE does not exist because it's not including at that point. But yes, we can see it would be at 0, 1. But it's not including that point 1 because it's open there. All right, now our range is going to be different on this one because we have open and closed circles. Our range is always still talking about the y values, but we're going from low to high on the y value. So I'm talking about the y. If I follow this parabola, how low does it go?
Four.
Well, that's the x though. How low? We're talking about the y's.
Four.
Yep, it's at 0 right there. That's the lowest it goes. So the lowest is at 0, less than or equal to y. Okay. And then how high does the graph go? Yep, right here. This is the height, is the max right there. I'm going to point to the height it goes. It will be less than or equal to 5. So there's your range. It's an inequality. Your domain, this is when we're looking at left to right on your axis. So go all the as far left as you can. You see right here on the x-axis, this graph starts where 0 again, and it goes all the way on the x-axis to. So this would be 0 is less than x, because there's an open circle there, which is less than or equal to 4. Are these attributes making sense? Because I'm going to ask questions on this. Okay. All right. So either giving you equation or giving you a graph. All right. So we look at our next part. Now we got to interpret the graph. We got one at the bottom, right? Are y'all with me here? The example here says the height of a soccer ball kicked into the air can be modeled, okay, by the equation. So we're talking about the soccer ball kicked into the air. That's what we're looking at as the model. The graph that they give you over here, sorry, this graph is the model of the kick. So you still have to, we understand that's the path and that's what's happening. So we got to interpret what's going on. So off the graph, we can read our zeros, our roots, our intercepts. What are the intercepts? Yeah, 0 and 3. So x equals 0, or if you want to look at it as a 0.00, and x equals 3. That would be the 0.30. Now, let's interpret that. What do these values represent? Time. Okay, so what is this really time measuring? What is this modeling here? The beginning and the end. Okay, so this time, this right here is our ball getting kicked, right? So this is the time the ball is in the air, right? Because it gets kicked over time and then it comes down. So we can say that the ball is in the air how long? 3 seconds, right? From 0 to 3. So 3 seconds. Make sure you can interpret that. So if x is your time, then the y-intercept, what would that represent? Okay, but the y-intercept, you're right. The path of the ball is our parabola, but where is the y-intercept? Just think about the y-intercept. Where is it?
Yeah.
It's at 0, okay? 0, 0. There's your y-intercept right there. How do we interpret that for this model?
The ball started at.
Yeah, the ball started at 0, okay? The ball, it starts at 0. Well, what does that really represent? If we start at 0, where is that? Yep, 0, which is on the ground. Okay? Ball starts at 0, which is on the ground. So we start the kick on the ground. Okay? Now, the max and minimum value. Does this model have a max or a minimum? Max. Okay, what's our max value? Yeah, this would be 35, right? In between 30 and 40. So this would be, I would say 36. So the max value is 36. How will we interpret that? What does that represent? The highest the ball got. Yeah, the ball reached a peak of 36 feet. Yeah, that would work. Very good. So we can physically draw that. Y'all saw that it's in between 1 and 2. So our axis of symmetry is x equals 1.5. So where is the vertex? Think about it. Yep, 1.5 comma 36. Okay, so like I said, you're going to be given a graph or an equation. Yeah. Now, we're going to make sure you understand your transformations. Okay, so the next tab is dealing with transformations, right? Or did I skip one? Yeah. The top of it talks about quadratic functions. And it talks about the parent function. So the parent function equation is y equals x squared. Add that to your flip book, please. Y equals x squared. Now, I want you to complete your table and sketch the graph. Yes? A couple things I want to just recap. Remember, the middle here is what part? Always. Yeah, the vertex. Okay. So your vertex is always in the middle of your table. And then remember how we have a pattern here? They get reflected over that vertex. All right, so last part, let's fill in our attributes. If we got the hang of it, let's just do it. Our vertex is at what point? 0, 0, done. Do we have a max or min? And our value? 0, good, done. Axis of symmetry. So x equals 0. Y-intercept? 0 again, done. Domain? All real numbers. Range? Something was 0. What is the something? Y? Yep, y is greater than or equal to 0. And our x-intercept? 0. There's only one root here, okay? So there's our parent function. Everything we transform is from this function. So underneath there, just kind of recap some things. All right. For translation, this is when you just add or subtract, okay? If we're talking about vertical, underline the word vertical, that's usually the K in the vertex form. And then I just drew arrows up or down. So vertical translation is going to move up or down. That is your K. Your horizontal translation, that is the H for horizontal. And then I drew arrows pointing to right and left. This is when we're going to translate, shift left or right. Now, dilation, I put times this multiplication, but I mean that you're going to have to times. You're going to multiply when dealing with dilation. Dilations are what changes the shape of the graph. This makes it wider or skinnier, okay? So I just kind of keyed the key part. I might need to move this up a little bit because this is talking about a times the function. If a is greater than 1, then it's going to be a stretch vertically. Meaning it will get right here, where is it, narrow. Or if you can think of it as getting skinny. Yeah, on a diet. I know she likes that. I don't know. If it's between 0 and 1, it's a fraction. You do. You like that it's on a diet. If a, what we're multiplying is between 0 and 1, talking about fractions or decimals, that's what makes it wider. It needs to go on a diet, okay? So, and then this reflections are just sign changes. I just wrote sign change because we're going to have a negative outside the function or a negative inside the parentheses to the variable, okay? So all I wanted us to do here, oops, I forgot, oh, I already showed you, is your first function, f of x, is the parent function. All right? So we're going to describe how it's changing. Oops. That's not what I wanted. Okay, so what do you notice on the G sub x? Something you see. The first one is the parent, x squared. But then if I look at the G sub x, what did I do to that parent? How does it change? What do you see? Yeah, okay, so this right there, I'm drawing an arrow to that negative. How does that transform it? That is a reflection, yeah. So this means it's going to reflects over what? It's the x-axis. Okay. Reflection over the x-axis. Okay. Now, we also heard the +3. So what is this telling me?
Translation.
It's a translation. How? Yep, it goes up. How many?
3.
Yep, up 3 units. There we go. So we had a reflection, and it shifts up 3 units. Okay, so in example 2, again, the x squared is your parent. So now we change this parent by doing 2 parentheses x plus 3 squared. What is this 2 doing to the graph? It is a dilation. Okay. What type of dilation? Huh? Go back and read, guys. What type of dilation? Which one? It is going to go narrower. You're right. So that means we're looking at a vertical stretch right here. So we have a vertical stretch to make it narrow. Okay, so dilation slash, sorry, that's a V, stretch by factor of 2. Okay, so there's that. Do y'all see this part inside the parentheses? How is that changing? Okay, so what does that mean?
Vertical translation?
Oh,
what? Horizontal.
It's horizontal translation.
To the right?
If it's +3, it's not to the right.
To the left?
Yeah. To the left 3 units. Okay. But yes, you're right. This graph, because we had greater than 1 right here, this graph, sorry, it is going to be narrow, sorry, or slash skinny. Okay. Your graph is going to be narrow or skinnier to the parent. All right. Now, on example 3, how is this changing? What would this do to the graph?
It's gonna get smaller.
What's going to get smaller?
It's gonna be a horizontal streak.
Dilation.
It is a dilation.
Horizontal stretch.
Yep, it is a horizontal stretch.
That's weird.
I'm running out of room, sorry. So, how is that going to affect the shape of the graph?
It's gonna get smaller.
It's going to get wider.
Yeah. The first one is longer because
It's going to be wider than the parent function.
Oh my goodness, why are you guys doing that?
Do you know the difference between what makes it wider and skinnier?
the fraction, if it's bigger.
Yeah, if it's bigger than 1, it gets skinnier. If it's a fraction or decimal, it's wider. Okay. All right, so that takes care of transformations. Our next section on our book, flip book, forms of quadratic equations. So writing equation. Okay, so this is what the standard form, this is will be given to you on your formula chart. You just need to underline right here, the C in standard form is your y-intercept. So that would be 0, comma, C. Whatever the constant is. And then your axis of symmetry, it's the formula x equals negative b over 2a. And you just have to remember to plug in your parts in the quadratic, meaning your a, your b, and your c. We got to know those parts to solve. Vertex form is given here. Your vertex is the h, comma, k. The h value and the k value are your vertex. Your axis of symmetry is x equals the h value. Don't worry about factor form. We don't need that right now, okay? Now, this is what we did yesterday, so I want to see how well we retained it. I'm going to put a little star here. It says converting from vertex form to standard form. What would be our first step here?
Put x plus 1, x plus 1.
Be a little bit more specific.
Like
Negative 3.
Parentheses, x plus 1, parentheses, x plus 1, minus 2.
Right.
Okay. All right. So the first thing we did was expand. That's calling expand your parentheses squared. That's what we did first.
Sorry.
Okay. Now that we did expand it, what do we need to do now? Yeah, we need to FOIL. Okay, so the first, I keep the negative 3 in front. The first is the x times x. So that would become what?
X squared.
X squared. Okay, then the outer plus 1x. Inner plus another 1x. Plus 1. Then minus 2 outside the parentheses. Okay. Combine your like terms. Okay. Right there. So we got to put it as a trinomial. We need to simplify this. The negative 3 stays in front. We have x squared 2x plus 1, and then outside the parentheses minus 2. Now we distribute. Okay. All right. So the next step is distribute.
Now it's negative 3. So
Negative 3x squared. Okay. Then. All right.
Combine those like terms minus 5.
All right. Last thing is combine CLT. Combine like terms. So we have. Yeah, minus 5. There is your standard form right there. I'm just going to box that answer. Are we okay on that? Definitely going to ask you to do that tomorrow. All right, so the next page is talking about solving or methods to solve. So we're going to skip this writing from a point, but we did this one yesterday from a graph. First, you need to use your vertex form. I'm talking about that x, oops, sorry, forgot the first part. A parentheses x minus the h squared plus k. So from the graph, what do we need to find? What part do we need to use? The h and the k, exactly. So that is down here. What is our h and k? 1 comma negative 4. Okay, so when we plug it in, y equals, we don't have an a here. It's actually 1. It's an invisible 1. We would write x minus 1, parentheses squared, then minus 4. Okay. All right, so then we would do what? We would expand it. We go through the same steps, which will require us to expand this first. Remember, that would be x minus 1, written twice, then minus 1, or minus 4. All right, then we'll FOIL. Okay, so we're FOILing next. So FOIL means x times x here, x squared, x times the net minus 1, negative x, negative 1 times x, that's another negative x. But the negative 1 times the negative 1 makes that plus 2. Okay. X squared minus 2x plus 2. Then we had that minus 4. Oh, sorry, you're right. That's plus 1. All right, so what's our final equation in standard form?
1 equals x squared minus 2x minus 3.
Yep. All right, we're not gonna worry about linear factors right now. Okay, so our last section is solving. Methods to solve. You're gonna have to start putting that phone. You're gonna turn it in with this cell phone.
Okay.
Okay, I need you to add this to your table, please. Okay, let's talk about this last thing. All right. The first one is already given to you, the table. But I just want you to understand where to find your answer on a table. I wrote the note. Solutions are when y equals 0. Because that's what happens for it to be an x-intercept. The y has to be 0. So do we see where the y is 0 in the table?
Yes.
So what are our solutions? Right here, yep. So our solution is when x equals -1 and x equals +1. And we're done. What if I give you the graph? Where is the solution?
X equals -1.
Yep, the roots right there. X equals -1, x equals 3. There they are. I'm just pointing to where the solutions are. All right, now we can take square roots to solve. Okay, it says you can use this when there's no x term, no middle term. I just underlined the sentence. Isolate the x squared term on one side of the equation. So to do that, to isolate this is the 2x squared is the x squared term. I have to do the opposite of this. So that means you have to add 98 on both sides to isolate so you could eliminate that negative 98. So now we're going to write 2x squared equals 98. Now let's solve for the x squared. What do you think our next step should be? Yep, divide by 2. Okay, so we divide by 2. X squared equals 49. Now what are we going to need to do?
Square root.
Take the square root. Okay, so our answer is, no, plus or minus 7. Because a -7 squared is also 49. Plus or minus 7. All right, now, don't worry about completed square, but we should remember, let's see if you remember how to factor. What do we need to do here?
Find the GCF.
Do we have a GCF?
Yes. No.
No. Okay, so now what do we do?
Isn't it 2?
The X puzzle, okay, make your X puzzle.
18 and
18's on top, 11's on bottom.
92.
Yep, our factors are 9 and 2. So that means x plus 9, yeah, and x plus 2 equals 0. So when you're solving this, you solve each one. All right, we'll stop right there. Hey guys, just make sure you finish those quizzes because that's due tomorrow.